Alright guys, today we're going to go over 1.7 homework part 2. This is page 54 to 56. I'm going to start at 24 because 22 should already have been done on part 1 correctly. So the idea was you're supposed to try 22 before you learned about part 2 and then redo 22 to make sure it's correct. I did it correct in the last video. So 24 to 66 even. For this almost every single problem in this part, you're going to be using the steps for completing the square. So that means you're going to be the first thing you're going to do is make 1x squared plus bx on one side of the equation. That's a really big idea. We have to make sure we can do that. Once that happens, then you create c. That is done by taking b, cutting it in half, and squaring it. And the most common mistake that I see is people forget to add it to both sides. So make sure you add it to both sides of the equation. That should make a perfect square trinomial. So you can factor it in one set of parentheses squared. And because it has one variable, you now get to solve using PEMDAS backwards. So pretty much every single problem is going to look just like that. Alright, so 24 is x squared plus 6x minus 3 equals 0. Remember, that 3 is not perfect. I want to have 1x squared plus bx, so I have to get rid of that 3. So to do that, I'm just going to add 3 to both sides. Alright, so that makes this x squared plus 6x equals 3. Now step 1's done. So now I have to do step 2, which says create c. So I'm going to say c equals 6 over 2 squared. 6 over 2 is 3, so it's 3 squared, which is 9. Remember, I have to add that to both sides. So I'm going to add 9 here. I'm going to add 9 there. I always like to use a different color because now I can easily see that there is blue on both sides. Once that happens, this line now becomes x plus 3 in parentheses squared equals 12. Now I get to use PEMDAS backwards. So I'm going to get rid of the exponents first. So I have x plus 3. Now remember, whenever you square both sides, plus or minus shows up. And now I subtract 3 from both sides. Now don't forget, 12 is not perfect, but 4 goes into it 3 times. So it becomes 2 radical 3. And that's my answer. Remember, that's 2 different answers. I could write that as 2 different answers. And that's it for 24. Alright, 26, we have x squared minus 18x plus 86 equals 0. So once again, I want to make x squared plus bx show up. So I have the x squared and the bx, so that means I got to get rid of the minus 86. So to do that, I'm minus 86 from both sides. Pretty easy. So then we're going to have x squared minus 18x. And I always leave the space here between the 18x and the equal sign. That just saves me a line later. Now that I have step 1 done, step 1's done, I get to do step 2. It says create c, so c is equal to negative 18 all over 2 squared. That's negative 9. I'll make sure it's in parentheses because remember, no matter what, this c should always be positive. So I'm going to add 81 to both sides. Remember, I like using the different color because now, look, it's really easy to see that there's blue on both sides. So the blue writing came from me using completing the square. I just made it up, and I'm allowed to do that as long as I add to both sides. So the left side is a perfect square trinomial now. So it turns into x minus 9 squared. The right side, negative 86 plus 81 is negative 5. Now I get to use PEMDAS backwards. The subtraction is inside the parentheses. There's no addition, no division, no multiplication. There's an exponent, and that's why I square root both sides. I have x minus 9 equals plus or minus. Remember, a negative inside the radical turns into I. And then I add 9 to both sides. Remember, since the plus or minus already happened, the 9 goes in front. Goes in front of the plus or minus. So your final answer should be x equals 9 plus or minus I radical 5. And that's it. Remember, I could make you split that and say 9 plus I radical 5 and 9 minus radical 5. So remember, that is 2 answers. And that's it. All right, 28. We have 2k squared plus 16k equals negative 12. So remember, step 1 is we want to make 1x squared. So this 2 is messing everything up. So to fix that, I just divide everything by 2. Like I said, that works because everything is divisible by 2. So this becomes k squared plus 8k. And I leave a space. Remember, I leave a space on purpose, equals negative 6. Now step 1's done. So I get to move on to step 2. Step 2 says create C. So that's where I'm going to say C equals 8 over 2 squared, which is 4 squared, which is 16. So remember, the rule is to add that 16 to both sides. So I add 16. Remember, I always try to use a different color because now it's really easy to see that I have 16 on both sides. So the left side right here, this turns into k plus 4 squared. The right side turns into negative 10. Now I'm going to use PEMDAS backwards. So there is no subtraction, there's addition, but it's inside the parentheses. No division, no multiplication, there's an exponent, and that's why I square root both sides. Alright? So I end up with k plus 4 equals plus or minus. Remember, the negative inside the radical turns into an I, and then I have the square root of 10. Now I can minus 4 from both sides. I'm getting rid of the addition because the parentheses are gone. I have k equals negative 4 plus or minus I radical 10. And that's it for 28. Alright, number 30, I have 4x squared minus 40x minus 12. Now remember, you cannot have, step 1 says to make 1x squared plus bx. So it doesn't matter to me whether you get rid of the 12 at the end first or you divide everything by 4 first. I think usually you guys get scared of that number being bigger than 1. So the first thing I'm going to do is divide every single thing by 4. So that's going to change this into x squared minus 10x minus 3 equals 0. Now I still need x squared and 10x all alone, so I'm going to add 3 to both sides. Alright, now that gives me x squared minus 10x equals 3. Now that step 1's done, I get to do step 2. So c equals negative 10 over 2 squared, which is negative 5 squared. Remember, negative times a negative is a positive. Make sure it's in parentheses if you're using a calculator. It will spit out 25. Alright? Now look, there's blue on both sides. Also, the left side is now a perfect square trinomial. So the left side turns into x minus 5 squared. The right side, 3 plus 25 is 28. Now I'm going to use PEMDAS backwards. I have to square root both sides. Remember, when you square root both sides, plus or minus shows up. Now I can add 5 to both sides. Now, don't forget that 28 is not perfect, but 4 goes into it 7 times. So this 4 right here, that goes into 28, turns into 2. 7 stays in the radical the whole time. So the best answer is 5 plus or minus 2 radical 7, and that's it. Alright, so 32, very similar to 30. The biggest thing that's stopping me right now is this 7 is making everything difficult. But the good news is everything is divisible by 7. So I'm going to divide every single thing by 7. Remember, if you divide with the pluses and the multiple terms on the left side, you have to divide everything by 7. Not just 7t squared. You have to divide the 28 and the 56 and the 0, or you're not keeping balance. Alright? So I end up with c squared plus 4t plus 8 equals 0. Now, I still don't have 1x squared plus bx because I would need to get rid of this plus 8. So to do that, I minus 8 from both sides. Now I end up with t squared plus 4t equals negative 8. Remember, I like to leave that space on purpose. I also like to change color when I do step 2. Now I'm on step 2. C is equal to 4 over 2 squared. Well, half of 4 is 2. 2 squared is 4. So I'm going to add 4 to both sides. Make sure there's blue on both sides. That makes it so you didn't mess up. Now the left side is a perfect square trinomial. So the left side turns into t plus 2 squared. The right side, negative 8 plus 4 is negative 4. Now I get to do PEMDAS backwards. I square root both sides. T plus 2 equals the negative right here turns into I, and 4 is perfect, so it's just 2I. And don't forget, you square root of both sides so the plus or minus shows up. Now I get the minus 2 from both sides, so the best answer is going to be t equals negative 2 plus or minus 2I. And that's it for 32. Alright, 34. X squared plus 10x plus 8. So this is a little bit easier than the last one we just did. So when I do step 1, remember, I need x squared and x all alone. So the first thing I'm going to do is I'm going to minus 8 from both sides. Now I end up with x squared plus 10x equals negative 13. So now I have step 1 done, so I get to move on to step 2. Well, that says we're going to say c equals 10 over 2 squared, which is 5 squared, which is 25. I'm going to take that 25, I'm going to add it to both sides. Alright, so the left side becomes x plus 5 squared. The right side becomes 12. Now I square root both sides. X plus 5 so I end up with x plus 5 equals plus or minus the square root of 12. I subtract 5 from both sides. So I have x equals negative 5 plus or minus. Now remember, 12 is 4 times 3. That 4 turns into the 2 outside the radical. So the best answer is negative 5 plus or minus 2 radical 3, which is answer C. And that's it for 34. Alright, 36 with the area of a parallelogram. Well, the area is equal to base times height. And the area is equal to 48. So I'm going to write an equation. 48, that's the area, is equal to the base, which is x plus 6, times the height, which is x. Now, I want this to look like something I've done before, so I'm going to distribute the right side. And the right side is going to turn into x squared plus 6x. 48 is going to go on the left side, or the right side. Now, this looks like something we've done before, where I have x squared plus cx, or I have 1x squared and bx all alone. So after I did just a little bit of distributive property, it looks like something I've done before. So that means I'm going to go into c equals 6 over 2 squared, which is 3 squared, which is 9. Now remember, I'm going to add 9 to both sides. So the left side is a perfect square trinomial. So it turns into x plus 3 squared, where the right side, I do 48 plus 9 to get 57. Now I square root both sides. I end up with x plus 3 equals plus or minus the square root of 57. And I subtract 3, x equals negative 3 plus or minus the square root of 57. Now, because this is a figure, there's only positive answers. So the answer is not x equals negative 3 plus or minus radical 57. The answer is only x negative 3 plus radical 57. The minus does not work. All right, and that's it for 36. All right, so 38 is using a trapezoid. The hardest part about 38 is actually knowing which formula to use. Here is a variation of the trapezoid area formula. 1/2 times the height times base 1 plus base 2. Basically, a lot of times you see b1 plus b2 over 2 times h, or some variation like that. So this is just one way to write it. So I'm going to plug all my numbers in. The problem told me the area is 20. Then we have 1/2. The height is x. Base 1 is x plus 9. Base 2 is 3x minus 1. So before I do anything, I'm going to combine my like terms in the middle, inside the parentheses. So I have 20 equals 1/2 x. 3x and x is 4x. 9 minus 1 is 8. Now, this is all me trying to make 1x squared plus bx show up. So before I do anything, I'm going to distribute. Now I'm going to write all this on the left side just because a lot of you like the problem on the left side. So I have 2x squared plus 4x equals 20. The reason I can't do anything right now with my c and stuff is I have this 2 here. So to fix that, I'm going to divide everything by 2. So this is going to come over here. I'm going to have x squared plus 2x equals 10. Now that step 1's done, I have x squared and bx all alone. I get to do the c. c equals 2 over 2 squared, which is 1 squared, which is 1. So remember, I add 1 to both sides. Like I said, I like to do it in a different color. It's really easy for me to see right now that I have added 1 to both sides. So the left side, this left side is now going to turn into x plus 1 squared. The right side is going to turn to 11. Now I can square root both sides. I end up with x plus 1 equals plus or minus the square root of 11. Now I subtract 1 from both sides. Now remember, because it's an actual figure, the length has to be positive. My only answer is negative 1 plus radical 11, not plus or minus. And that's it. 40 will be an accuracy problem. I will help you get. And so we have y equals 0.0085x squared minus 1.5x plus 120. Now, remember, the first thing you want to do is you're going to subtract the 120. If that y was not there, I would just divide everything by that decimal in front of the x squared. But that y is there, so it makes everything really messy. So the first thing I do is I just get rid of that y. Now I can't divide because it's just going to get really messy, so we have to do this idea of factoring. So I don't know if you remember, but in class we said we took this number right here and we put it outside the parentheses. So it should look something like this. So when you take this number out and put x squared here, you have to take this number and divide it by 0.0085. So you do negative 1.5 divided by 0.0085. It's going to be kind of messy. All right. Then you have to find a new c. And that new c then you have to find the new c. Remember, whenever you add that new c, you have to multiply by this number out front in order to add it to both sides. Okay? So that's going to be an accuracy problem. Going to probably get a little bit of help on that if you've waited to the last second to do that one. All right? So that's it for 40 for now. All right, so on 42, it's slightly different because we have a problem that looks like this. It's called standard form. There's no parentheses. We want to use completing the square to make it look like this, vertex form, where it has one set of parentheses squared. So you're still going to follow the steps for completing the square. It's just going to be slightly different. So step 1 still says make x squared and x all alone on one side of the equation. So to do that, I'm going to add the 1 both sides, just like we did before with the number. The only difference is y and 1 can't go together. That's it. Now the right side is still ready for step 2. It's still x squared and x, so I still get to do my c equals. But this time I do by b, just like I normally do. I get negative 2 squared, which is 4, and I add that 4 to both sides. So see how there's a c on the left side, a c on the right side. I add to both sides. So this turns into y plus 5 equals, and the right side is a perfect square trinomial. It turns into x minus 2 squared. Now the only difference between this line right here and this answer vertex form is that there is y by itself. So to get y by itself, I just subtract 5 from both sides. So my actual answer for this problem, the answer is just this. Y equals x minus 2 squared minus 5. Now, you got to tell me a, h, and k. So a is 1. It's always the number in front of the parentheses. There isn't one, so it's 1. H is right here. Remember, it's a dirty h. We don't trust that dirty h hanging on their x. So although it looks like negative 2, it's actually positive 2. K right here. Remember, k is cool. We trust them because they're not hanging on their x, so it's negative 5. The vertex is h and k together. So that's the vertex. This is the answer. This is the vertex. They want both. All right, that's it for 42. All right, so 44 is very, very similar to 42. So the first thing is we want to make x squared and x all alone. So to do that, I got to get rid of the 90. Now remember, y and 90 can't go together, so the left side just turns into y minus 90. The right side is the way we want it to be, so now we can find c. c equals to 20 over 2 squared, which is 10 squared, which is 100. So I have to add 100 to both sides. I have to add 100 to the left side. I have to add 100 to the right side. The left side turns into y plus 10. The right side is a perfect square trinomial. It turns into x plus 10 squared. Now remember, y can't be by itself, or y has to be by itself, so I have to subtract 10 from both sides. So your answer is going to look like this. Y equals x plus 10 squared minus 10. So when I find a, h, and k, a is 1. H, remember, it looks like a positive 10. It's a dirty h, so we don't trust them. K is cool, so we trust them. So that means my vertex is at negative 10, negative 10. And that's it for 44. Alright, so 46, just like 42 and 44, I have to get x squared and x all alone. So the first thing I'm going to do is minus 2. A lot of people already get confused about the g of x. G of x is just a fancy way to say y. So the left side should look like g of x minus 2 equals x squared plus 7x. Now I'm able to do c. C equals 7 over 2 squared. I don't care if you give me a decimal. I'm going to leave it as a fraction. I think it's easier that way because I just square the top and square the bottom. I get 49 over 4. or I get 10 and a fourth. So I'm going to add that to both sides. Alright. So the left side becomes g of x plus 8 1/4. And the right side, this is a perfect square trinomial. Every problem we've done, whatever has been divided by 2, that's what goes inside the parentheses after it's factored. So if b would have been 8, I'd put 4 inside the parentheses. If b would have been 10, I'd do 10 divided by 2, which is 5. That's what goes inside this parentheses next to the x. So I'm just going to put 7/2. Now I minus 8 1/2 over. Or 8 1/4, I'm sorry. So my answer I made a silly mistake over here. 49 is not 10 1/2. It is 12 1/2. Or 12 1/4, I mean. Which makes this so let's fix all this. We're going to go back a little bit. So this is not my mistake on purpose, guys. I just went kind of dumb for a second. All right. Let's kind of reset a little bit. So let's go back. 49 over 4 is 12 1/4. So I add 12 1/4 to both sides. That makes way more sense. So this becomes 10 1/4. And that means I have to subtract 10 1/4 from both sides. So sorry about that, I just had a dumb moment. So I minus 10 1/4 minus 10 1/4. So my final answer is going to look like this. G of x equals x plus 7/2 squared minus 10 1/4. So A is 1, H is negative 7 over 2, K is negative 10 1/4. So my ordered pair for my vertex is going to be negative 7/2, negative 10 1/4. Alright, and that's it. So there's your equation, there's your vertex. And that's it for 46. Alright, so 48 is very similar to 46. It's just a little bit harder because the number in front of x squared is bigger than 1. And the reason it's difficult is because I cannot divide everything by 5. Because I can't divide y by 5. So I still have to make 1x squared plus bx show up. I just have to do it a little bit different. So the first thing I'm going to do is I'm going to get rid of the 7. Because that's pretty easy to do. I'm going to write y minus 7 equals 5x squared plus 10x. Now I have to figure out how to get rid of this. So I need to figure out a way to get rid of this 5. I can't divide because not everything is divisible by 5 because of the y. So what I'm going to do is I'm going to make 5 go outside a set of parentheses. That's like undoing the distributive property. So I'm allowed to do that as long as I divide both of these by 5. So that works. So inside the parentheses I have what I want. I'm just going to keep the left exactly the same. Now that I have what I want inside the parentheses, I can do my c equals 2 over 2 squared. 2 over 2 is 1. 1 squared is 1. So I'm going to add 1 right here. Normally, I add 1 on the other side. The only problem is this 5 affects the 1. So I really didn't add 1 on the right side. I actually added 5 times 1. So I actually have to add 5 on the left side. So whatever's outside that parentheses, in order to save myself from dividing, I actually have to multiply that by that before I add the number. So the left side becomes y minus 2. The right side becomes 5 because that's 5. and the parentheses becomes x plus 1 squared. Now I add 2 just like I did earlier. So my best answer is y equals 5x plus 1 squared plus 2, where a is 5, h is negative 1. Remember, we don't trust that dirty h hanging out with our x. And k is 2. That makes the vertex negative 1, positive 2. So there's your equation, there's your vertex. And that's it for 48. All right, so 50. They made a mistake somewhere in this problem. This line right here, good because it's the original problem. This line is good because they got rid of the 13. This line, they got 25 by finding a new c, 10 over 2 squared, which is 5 squared, which is 25, and they add to both sides, so that's good. They factored this correctly, so that's good. They remembered their plus or minus after they square root of both sides, so that's good. They moved the 5 over. That's good. The only mistake they made is the square root of 4 is not 4. When I take the square root of 4, I have to change that to a 2. So the only thing they did is they made a little mistake in the last line where it should be 2 radical 3, not 4 radical 3. And that's it for 50. So I'm going to go a little bit faster now because 52 is a very simple problem from what we've done before. So remember, I want to get x squared and x all alone, so I minus 20 from both sides. I end up with x squared plus 9x equals negative 20. Now I get to find my new c. c is equal to 9 over 2 squared, which is 81 over 4. So I'm actually going to add that to both sides. So I'm going to put 81 over 4 here and 81 over 4 here. Now, believe it or not, 81 over 4 is 20 and a quarter. So this is actually perfect. So it's going to become x plus 9 over 2 squared equals 1/4. So I use pendulums backwards. I square root both sides. I end up with x plus 9/2 equals plus or minus 1/2, because I take the square root of the top and the square root of the bottom. They're both perfect. So x equals negative 9/2 plus or minus 1/2. Because there's no radicals, I actually have to split it out, where I do negative 9/2 plus 1/2 to get negative 8/2, which is negative 4. And I get x equals negative 9/2 plus minus 1/2, which is negative 10/2, which is negative 5. 2 answers, done. All right, 54. The first thing I have to do to 54 is I have to put the q squareds on the same side. Because remember, you can't really do anything until all your like terms are combined. So I have 5q squared plus 10q equals 155. I can't find c yet because I have a 5 in front of here. So to fix that, I'm just going to divide everything by 5. So now I have q squared plus 2q equals 31. Now, I can find my c. So c is equal to 2 over 2 squared, which is 1 squared, which is 1. So I add 1 to both sides. So the left side becomes q plus 1 squared equals 32. Now I can square root both sides. I end up with q plus 1 equals plus or minus the square root of 32. I can subtract 1 from both sides, and I'm going to simplify the radical. 16 times 2. So the answer is going to be negative 1 plus or minus 4 radical 2. And that's it. Alright, 56. Although 56 seems a little difficult, it's actually, you guys just get scared of the decimals. So if you don't like those decimals, here's what I'm going to do to fix that. I'm going to multiply everything by 10. I see tenths, like 1/10 and 2/10. So if I multiply everything by 10, all the decimals disappear. I end up with x squared minus 10x plus 90 equals 2x. So like I said, I'm allowed to do that as long as I do it to everything. I can't do anything more until I put the x's on the same side. So I'm going to subtract 2x from both sides. That gives me x squared minus 12x plus 90 equals 0. Now I'm finally allowed to start completing the square, where I minus 90 from both sides. And I end up with x squared minus 12x equals negative 90. Now that I did all that work to get x squared and x all alone, so I'm going to do c equals negative 12 over 2 squared, which is 6 squared, which is 36. I'm going to add 36 to both sides. So my left side is going to turn into x minus 6 my right side is going to turn into negative 54. Now I get to use Benjamin's backwards, square root both sides. I get x minus 6 equals plus or minus. Remember, the negative turns into I. 54 is not perfect, but 9 times 6 is 54. So I'm going to add 6 to both sides. And I'm going to turn that 9 into a 3 when I simplify the radical. So I have x equals 6 plus or minus 3i radical 6. And that's it for 56. 58 is easy. You're just writing any equation you want that says you can't solve it by factoring. But you could use completing the square. I could use completing the square because I could subtract 4 from both sides. This is not factorable. So that's a good answer. All you do is pick a problem that was not factorable that could be solved by completing the square. Almost every problem can be solved by completing the square, whether it's factorable or not. So that's it for 58. 60. For what values of k is there exactly one real solution? Well, for 60 they give you this, and it looks messy and scary, but really, guys, it doesn't really mean much. Basically, this is a perfect square trinomial. So whenever I use PEMDAS backwards, if k was 0, there's going to be one real solution. If k is greater than 0, it means it's positive, you'll have radicals show up in plus or minus, so there'll be 2 real solutions. If k is less than 0, then you're going to have 2 imaginary solutions, because a negative is going to show up inside the radical, and that's going to make I show up, which means not real. That's it for 58 and 60. Alright, so 62 is talking about a drum major tossing a baton in the air. He gives us this equation. They want to know the maximum height. Well, the max height is the k part of the vertex. So all you do is put this in vertex form. So I'm going to do exactly what I did before, where I'm going to subtract 6 from both sides. Now the problem is, I don't want this negative 16 here. So remember, I'm going to factor out the negative 16. Now I can find c. C, remember, you can't find c until you get that negative 16 out here. So the B is actually 2 because remember, to put this negative 16 out here, you have to divide this and this by negative 16. And that's why it should be negative 2. So we have negative 2 over 2 squared, which is negative 1 squared, which is 1. So I'm going to add 1. Now the problem is I'm not really adding 1. I'm adding 1 times negative 16. So I have to put minus 16 on this side. So this is going to become h minus 22 on the left side equals negative 16. And then the inside becomes t minus 1 squared. Now I have to add 22 to both sides. So my new equation is going to be h equals negative 16 t t minus 1 squared plus 22. So a is negative 16, h is positive 1, k is 22. That's your max height, so the max height is 22 feet. And that's it for 62. Alright, so 64, a store sells about 40 video games systems each month. When it charges $200 per system, for each $10 increase in price, they sell about one less. The store's revenue could be multiplied by this. Oh, I said that. That's 65. I read the wrong one. A skateboard shop sells about 50 skateboards per week for the price advertised. For each $1 decrease in price, about one more skateboard can be sold. The shop's revenue could be multiplied by this equation. Use vertex form to find out the maximize weekly revenue. So, remember, we want to know the max, so we need to know h and k. Now, I can't do much with this, so I have to FOIL it. So I'm going to get y equals 3,500 plus 70x minus 50x minus x squared. That's just FOIL, all right? Because I'm putting in standard form. This is intercept form. I'm going to combine my like terms. I'm going to rewrite it a little bit. Now, I'm going to complete the square. So I can't have this 3,500 here, so I'm just going to subtract it. And remember, this negative messes everything up. So I'm actually going to put negative 1 inside the parentheses. So now I can find c. c equals negative 20 all over 2 squared, which is negative 10 squared, which is 100. So I'm going to put 100 right here. Now remember, because that 100 is affected by that negative 1, I actually have to put minus 100 here because I have to do 100 times negative 1. So my left side is going to become my y minus 3,600 equals negative 1. Inside the parentheses it becomes x minus 10 squared, and I add the 3,600 over. So my answer is going to be y equals negative 1 x minus 10 squared plus 3,600. So, the maximum revenue is $3,600. H is actually 10. So I have to take my price of 50 and add 10 to it, so $60 a skateboard to give you a max revenue of 64. And that's it.